All right. Welcome to the last part of this where you are checking your answers or getting unstuck with these exercises. Exercise one, you're just figuring out the sign and approximate size of the solution. So, like, is t here positive or negative to make 4 to the power t become 22? And it should be uh, positive because 4 to a positive number will be bigger than 1. Well, let's think. 4 to the power 0 is 1. 4 to the power 1 is 4. 4 to the power 2 is 16. And 4 to the power 3 is 64. So 22 is a little bit bigger than 16, but much less than 64. So it's going to be somewhere between 2 and 3. Something like 2.2. Okay, so to actually solve it, we're going to take a logarithm of both sides. Do log of 4 to the power t, and also do log of 22. And log law 3 applies to this. You can take the t out, and you'll get t times log of 4 equals log of 22. Divide both sides by log of 4. And you'll get t equals log of 22 divided by log of 4 is going to be 2.2297. Yeah, so I was right about 2.2. There we go. Okay, so now let's think. We have 5 times something is 1/2. So is that 5 to the x? Well, we can look back at this rule we made a second ago. We have the 5 is bigger than the 1/2, right? So we have a larger number times a to the x equals a smaller number. So that means the x must be negative because the 5 to the x must be less than 1. So x being a negative number will make that happen. So yeah, we're going to say x is negative. Let's see, if x is -1, then 5 times 5 to the -1 would be 1. So it's less than that. I'm going to guess something like x is maybe -1.5, something like that. Let's actually solve it. So to solve it, I'm going to divide both sides by 5 first. Or over here, I'm going to write that as multiplying by 1/5. So that gets you 5 to the power x equals 1/2 times 1/5, or 1/2 divided by 5 is 1/10. And now if you take a log of that, then you could take the x out and write that as x times log of 5. Wait, log of 1/10 is -1 because -1 is the exponent of 10. That gives you 1/10. And then you can just divide both sides by log of 5 to cancel that out. And we'll get x is -1 divided by log of 5. And on a calculator, that'll be -1.699. Sounds good. Okay, for this one, let's see. I'm going to subtract the 3 from both sides first. And now we can think about what is the sign of x? Is x positive or negative? Well, if x is positive, 1.5 to the x is going to be bigger than 1. If x is negative, 1.5 to the x is less than 1. If x is 0, then it's equal to 1. So that's the sign of x, is it's neither positive nor negative, it's just 0. And that's also the solution to the equation itself, because anything to the power 0 is 1. Okay, so now let's look at exercise 2. We want to solve this equation. These ones, if you were stuck on them, my advice is look at example 7a here. This is pretty similar to example 7a. So you want to get the log by itself by dividing by 4. Eight divided by 4 is 2. And the logarithmic equation here you can write in exponential form as 10 to the power 2 is equal to 2x minus 6, which is just 100. So you can add 6 to both sides, and you'll get 106 equals 2x. Divide both sides by 2, and you'll get 53. Wait a second. I just realized after halfway through doing this problem that this is the exact same problem as example 7a. I don't know how I didn't notice that mistake before, but yeah, if you understood example 7a, then that really tells you how to do this problem, because it's the same problem. I better fix that. Oh well. All right, B is a little different though, and it's also similar to example 7a and exercise 2a. So that should give you some hints how to do this. All right, so I'm going to go ahead, assuming that you've tried this now. Let's subtract 8 from both sides. $17 minus 8 is 9. And that leaves you with log of n equals -3. And once you have just that log of n equals -3, you can rewrite it in exponential form. Because saying that log of n is equal to -3, that's saying that -3 is the exponent of 10 that results in n. So that's the solution, is 10 to the -3. You might write it as a decimal. 1.001 is n. All right, now let's look at exercise 3. We've got these two investments. So this one starts at $5,000 and then goes up by 6.2%. And the other one starts at $9,500 and then goes up by 4.1%. So let's solve the equation f of t equals g of t. So that means find the value of t that makes these two things equal. So I'm going to write that as 5,000 times 1.062 to the power t. That's the f of t is equal to that. And then the g of t is equal to the other part. Now, if you divide both sides by 5,000, or yeah, let's divide both sides by 5,000. To cancel that out, you'll get 1.062 to the t here. 9,500 divided by 5,000 is 95 over 50, which comes out to be 19 over 10, I think, or 1.9. Let me check that real quick. Yep. Okay. All right, now we want to get all of the t's on the same side. So I'm going to divide both sides by 1.041 to the t. because we have this multiplied here. Dividing will cancel it out, but you got to do the same thing to the other side. So now we can write this as just 1.9 on the right side, but something to the power t divided by something else to the power t. One of the exponent rules is that you can have them all just divided and then raised to that power. And now this is where you probably want to take a logarithm of both sides. Log of this whole thing equals log of 1.9. And log of this whole thing, the t is going to come out. You're going to write that in front using the log law. Log law 3. Now we can divide both sides by that log. And you're going to get t is whatever log of 1.9 over log of 1.062 divided by 1.041, whatever that comes out to be. Let's see. We got 32.137. So what does that tell you? T here is the number of years. So this is saying that after 32.137 years, the value of the two investments will be equal. And what that means is, well, the one started ahead. One started at 5,000, the other one started at 9,500. So you could draw a picture of the situation, get a super rough sketch. It would look like this. So one starting here at 5,000. The other one starting with almost twice as much. But the one with 5,000 has a bigger interest rate. It's going to end up going up faster eventually. And this one is going up not quite as fast. The point where they cross right there is 32 years. So that's what that tells you about the investments, how long it takes for them to have equal value. All right, so that is that. This is a tricky section, but we're getting some new methods of solving equations to go together with the old ones. Good luck with the homework. Up next is going to be 7.3. But before that, you've got the 7.2 quiz, where the problems are going to be kind of similar to what you had in this video. So good luck with that. Review your notes if you have to, and have a good day.